Welcome to Study Loop.
So let's say on the P versus V graph, we start at some point. We compress isothermally to a point where, let's say the initial volume is V naught, the final volume would be 0.22 V naught. Then we expand it adiabatically and it comes back to its original volume. Let's call these states 1, 2, and 3. Now, why does it look like this? Isothermal processes have the form PV equal to K, whereas adiabatic processes follow the law PV bar gamma is equal to K, where gamma is greater than 1. So, for a given value of volume, the value of pressure in the adiabatic case will be much lower. That is why adiabatic curves are steeper than the isothermal curves, which is why it is lower. Now, the first isothermal case, the process 1 is isothermal. So we simply use P1 V1 by T1 is equal to P2 V2 by T2. This gives us P2 is equal to P1 into V1 by V2. We know that the initial pressure was 1 atmosphere and the temperature was 273 Kelvin. So that gives us, because it's an isothermal process, the temperatures are the same. So the temperature here is 273 Kelvin too. Now, pressure is simply 1 atmosphere times, we know that V1 by V2 is 0.22 V1, giving us 4.545 atmospheres. So the pressure here is 4.545 atmospheres. Now, during process 2, the law followed is P1 V1 per P2 V2 per gamma is equal to P3 V3 per gamma, which means P3 is equal to P2 times V2 by V3 per gamma. So that's P2 was 4.545 atmospheres times V2 by V3 would be 0.22 V3 divided by V3 whole per gamma, where gamma, because it's a monatomic gas, would be 4 by 3. This gives us the value of P3 to be 0.3644 atmospheres. Using this, we can find the temperature too. We know that P1 V1 by T1 is equal to P2 V2 by T2, which means T2 is equal to T1 times P3 by P1 and V3 by V1, which gives us 99.48 Kelvin. Now, we want to find out the maximum temperature and minimum temperature and maximum pressure and minimum pressure. So obviously the maximum pressure corresponds to the highest point according to y-axis. So that's this point, which is at 4.55 atmosphere. So the maximum pressure is simply 4.5 atmosphere. And the minimum pressure obviously corresponds to this point, which is the lowest on y-axis. And this corresponds to 0.3644 atmospheres, or 0.36 atmospheres is good enough. Now for the highest temperature, all of these points on the first curve correspond to the same temperature, and that will be the highest temperature. So the highest temperature is simply 273 Kelvin, whereas the lowest temperature is a little tricky. Tmax and Tmin, yeah, Tmin is a little tricky. To see Tmin, you should know that PV per gamma is constant, means we can substitute for V, PV is equal to nRT, gives us V is equal to nRT by P, which gives us P power 1 minus gamma. P power gamma is a constant, which means P is equal to K by T power minus gamma by 1 minus gamma. So that's K by, so we can flip this over and write it as T power 1 by T power gamma by gamma minus 1. Now, if you see this, you can see that the larger the pressure, larger the temperature. Another way to look at it is to see that all the isotherms lie like this, and the isotherm that is closest to the origin corresponding to the lowest temperature will correspond to this lowest point. But that is beyond our scope, so let's not bother with that. Hence, the lowest temperature would correspond to this point, which is 99 Kelvin, as we have just seen. Now let's go through this once again. You can stop here, but let's go through this once again to solidify our foundations. Now, V is equal to nRT by P. When we substitute that here, we get P times T by P power gamma is equal to a constant. So that's P power 1 minus gamma. P power gamma is a constant. So T power gamma is equal to, let's forget all this. So T power gamma is equal to K P power gamma minus 1. Now, because gamma is greater than 1, this is a positive quantity, which means if T increases, P will also increase. And if T decreases, P will also decrease, which is why the point corresponding to the lowest pressure value is also the point corresponding to the lowest temperature value.